Hello everyone, and today's video is all about the applications. So here we are discussing the different applications or different ways of using our formula of the area of the triangle and the area of the parallelogram rectangle. So the first one here is you might be given a shape of a field like this, and you might be asked to find the area of this field. For these kind of problem, let's consider this as triangle 1, this as triangle 2, 3 and 4. As you can say that you are given the altitude of this triangle and the base of this triangle as A and B. So by the area of a triangle formula, you can find the area of the triangle. Let's call it triangle A, B and C. So you can find that area of the triangle ABC, which would become half AB. Now once you are having the area of this triangle ABC, you can call it as BDF. So you can have, it would be the same as the area of the triangle BDF, FGH and I. So all these four triangles area would be same. So we can say that the four triangles area sum up to 4 into half AB, which becomes as 2AB. So now the area of the triangles we have already got. Now we need the area of this square. So basically this whole field is sum of these four rectangles plus this square. So the total area will become the sum of the areas of the four triangles, that is 2AB, plus the area of the square, which will become B into B, because the length and the breadth both are B, so this will become B square. Substitute the given values of A and B and you will be able to find the total area of this field. Let's move to the next example. A shape given like this, maybe a lawn or a garden or a field. So when you are told about given this kind of shape, all you need to do is think about making a, let me just select the scale. So if you think about this is an enclosed figure inside a square whose dimensions you can say is B and B. Now you want to find, so what you want to find, what is this area? The area which is enclosed only in green boundaries. So let's first find the area of the rectangle or area of the square. So the area of the square will become as B square. Now how do we find the area of the enclosed figure? So the enclosed area is the area of the square, that is B square, minus the area of four triangles. Let's call this as triangle 1, 2, 3 and 4. So you can say that there are four triangles and you have to subtract. This area is omitted out of it. In this sum it was added in it, in this sum it is omitted out. So again the area will become as 2AB. It's the same, AB, so it will become 4 half AB. So the area of the enclosed area will become as B square minus 2AB. So this for different patterns can be given and you have to just see that you need to like join two rectangles, two triangles, or you have to remove some triangles or add some triangles. with the square or with the rectangle, and that way you will be able to figure out the complete area of the enclosed pattern. Let's take up one more example here. You are asked to find the area of this crossroad. So as to find the area of the crossroad, first thing what we can do is find the area of the big square, which is there in red. So the area of the big square, I'll just call A. Area of the big square is B square. Area of the small square, that is a blue square, is area of the small square is A square. Now from the big square, first I can do is can remove all the four squares. So area of the crossroad will become as area of the big square, that is B square, minus the area of small squares. But here we have 1, 2, 3 and 4 such small square, so it will become 4A square. Substitute the given values of B and A and you will be able to find the area of this crossroad. There is one more interesting twist in it. Sometimes you are asked that you have to just determine this area. Now how do you determine this area, which is in the center in the green? It's a little bit tricky but not impossible. Now if you see here, what is this length? This length is A, this length is A. So what will be this length? This length will become B minus 2A. Same way, if I see this length or this length, this will become A, so it will again become B minus 2A. So the area of this green pattern or a green square will become B minus 2A, that is the length, into B minus 2A, that is the breadth. That will give me B minus 2A, the whole square. Well, wow, you are now able to do the area or find the area for the any patterns. Let's go to the next one with something like this pattern. You're given to find the area of this pattern. In these cases, it's better to just draw a line. Let me just go back and draw a straight line, which would be more. Okay, so in this case, if you see that the total area of this tube, you can say is 1, 2 and 3. It's 1 plus the area of 2 plus the area of 3. Now what would be the area of 1? Area of the first rectangle can be given as BC, where B is the length and C is the breadth or the width. The area of the second rectangle. Okay, now comes the tricky part. So here you have this as the length. Now how do you determine what is this? Can I say that this hole is A minus C and minus C? So this is A minus 2C. The C length from the end, the C length from the start, both are subtracted from the complete length A will give me A minus 2C. So the area for the second will become A minus 2C into what? Into A. Plus what is again the third one? It is B, C. So the answer could be 2BC plus A square minus 2AC. Or in other words, it would be 2C B minus A plus A square. There is another way of finding it out, and that would be, instead of joining this line, you can join this line and you can join this line, find this area, find this total area, and find this area. I leave that to the readers who are listening this video, and yeah, for them to determine, are they getting the same answers? Both the areas should be same. Let's go to the next one. So I have given a field in a pattern of I, and I want to determine the area of this field. For this, again, we would be dividing this in different rectangles. Let's take up the first rectangle. Just a second. Okay. Well, there's something going fishy over here. Let's just okay. See, I was saying something's going on fishy over here. Well, let me just try this. See, it's working now perfectly. So, how to find the area? Let's consider this as 1, this has the second one, and this has the third figure. So the area is given as 1 plus 2 plus 3 rectangles. So it's the area of rectangle 1, 2 and rectangle 3. How will you determine the area of the rectangle 1? The area of the rectangle 1 would be given as A into this. Okay. Now, how do you find what is this breadth? This is 2C and this is 4C and this is C. So safely I can assume that this would be C because this is C. So basically 4C minus 2C minus C will give me as C. So I can safely assume that this and this are both same and it is C. So it will be a C plus. Now I have this second part. The length is 2C and the breadth is not given. So the length is 2C, the breadth is not given, but we know that this breadth is B As they both are symmetrical, we can safely assume that this breadth is also B, so it will become 2C A, this complete length A minus 2B. So 2C into A minus 2B plus the third rectangle. Again, the third rectangle, the length is same as A and the breadth will become as C. So here that would give us AC plus 2C 2CA minus 4BC plus AC. So that is 2 plus 3 plus 4, 4AC minus 4BC. If you want to give it in a simplified form, you can say 4C A minus B. Substitute the given values of A, B, C and you will be able to find the area of this pattern. That's for now. Now this video was mainly to give you an idea that you can break down any given pattern into the simple forms of triangles, rectangles and square, and then by adding or subtracting bigger triangle from a smaller triangle or bigger square from a smaller square or bigger rectangle minus smaller triangle, you should be able to derive a pattern so that you can find the area of the given pattern. I hope that makes clear with this video. Thank you for now. We'll meet in the next video.